I want us to start. Can you hear me? Can you all hear me?
Yes.
Yes.
I'm presenting something here. Can you see that?
Yes.
Can you all see that?
Yes.
Can you all see that? I'm only some few people responding. I'm three. What are
No.
you seeing? Can you see what I'm presenting? What are you seeing? What are you seeing?
Sequential structures.
Someone is saying she's not seeing. So I'm asking, what is she seeing? So I'm assuming that you cannot see what I'm presenting, right? I'm assuming that you are all seeing, right?
Yes.
Now make sure you mute your background. Make sure you mute the background so that there is no noise from the background. Aaron, are you seeing what I'm presenting? Caroline, can you see what I'm presenting?
Yes.
Okay. Now, I want us to start on control structures. And if you remember the programs that we've been writing, those programs are normally executed sequentially. And when I talk about sequentially, I mean the program is executed right from the top, from where you have maybe the header file, to the main, to the declarations, to the body of the program, the output, and the program exits. So you can see that execution is just what we mean by sequential. Sequential is the execution, the running of that program starts from the top in that line
Okay.
until you get the output. That is what we mean by sequential. Sequential as in one line after the other. Okay? If you look at the program for finding the area of a circle, the program for modulo, the program we did yesterday for the increment and decrement operators, is that sequence from the top up to the last line, then the output is displayed. That is what is meant by sequential. But there comes a time when that flow, that sequential flow, there comes a time when that sequential flow needs to change. Okay? Because not all programs will be executed in that manner from the top up to the bottom. Not all programs will be executed in that manner. But what I'm saying is, so far, the programs we've been writing, the execution has been sequential. the execution has been one line after the other, right from the top up to the bottom. This is the output. That is sequential. But now, a case whereby you want to make some decision. You see, for example, the normal trend, as in when you are in college, after the class you go back home, right? There is that route which you normally follow. I hope you can hear me, right? Hear me?
Yes.
Can you hear?
Yeah. Yeah.
Now
Yes.
there are some routine activities. Like I was saying, maybe when you're through the class, you walk back home. Okay, but the road is closed. The normal road you've been using has blocked. To change your direction, an alternative route. You see that? So the normal walking has been changed. That route which we've been using as the normal movement, that normal sequence of walking from college to the house has been changed. Okay? I'm using that example to help you see that the road is not blocked. You walk from college, that is sequential. Okay? But there comes a time you find the road maybe is blocked, maybe some construction is going on, or that route has been blocked, someone is constructing a house, so you have to change the direction. So that sequence of movement that you're used to has to change to find an alternative route. So you see, the moment you're changing that route, it means you are taking another route, a route which you're not used to. Okay? So the same applies in programming. Sometimes what you want to do, that sequential flow to change its direction. Okay? That sequential movement, that sequential flow of program execution from the header file up to the last line when the output is displayed has to be changed because maybe you want to make some decision. Okay? Maybe the program before it moves to the last line of execution. So that's where we have the control structure coming in. Okay? So let's say you want to write a program to display maybe to determine whether someone or a program to categorize people based on their age or based on their gender. Okay? So the program will start executing from the top, but up to some point it finds where it will be asking you whether you're a male or a female. So if you're a male, move to the left. If you're a female, move to the right. You see that normal sequence has been changed because of that decision which has been made. Okay? The program is running, but up to some point you are being asked whether are you male or are you a female. So based on your response to that question, a different direction will be taken. Because if you're male, maybe move this room. If you're a female, move that room. So you see that sequence has been changed based on your response to the question which has been posed. Okay? You're walking home and then you find the road blocked. You have to change your direction. You're walking, the road is blocked. All right. So that's where this idea of control structure is coming. It helps us to go about such kind of situation whereby you have to make a decision. Okay? You see, if you're walking home and the road is blocked, The question is, do I go back to college, or do I stand? Do I wait for that door to be open, or do I use another route? See, those are questions which come in the mind. Yeah. So that requires some control in your mind. Or it requires some decision to make. It's either you go back to college, or maybe you use another route, or you stop there. So the decision is yours. But whatever you decide, that it means the flow, your movement has been changed. How you are moving has been changed based on the action or the decision you're going to make. And that's exactly what we are saying here, that in some environments, this sequential flow and execution might be changed and the control transferred to another part of the program. So you see, when the program is running and you are asked whether you're a male or a female, if you say you're a male, then that control, that movement is transferred to another part of the program. Because if you're a male, then you should be doing something. The program should be doing something. If you're a female, the program is also changing its course to react on the fact that you selected as being a female. Male is supposed to do this, so the program will indicate that. If you're a female, the program is
Excuse me.
that same. So the control is being transferred to another part of the program. Okay? And in such environments, execution flow control are used. Okay? Now, if you look at the control structures, these control structures, they are statements that controls the flow of execution in a program, okay? Or the order in which statements in a program is going to be executed. See that these control structures, they want is to control the flow, okay? Control the flow of the program execution, or they control the flow in which the statements in a program are to be executed. See that? So what we need to do is to look at those control structures, because there are different types of control structures. I've said these control structures, they're used to control the flow of the order in which a statement is being executed. Now, these control structures, we have the type of control structures. Okay? We have types of control structures. Number one is the sequence structure, the straight line path. And this is the one that we have been uh, putting in use. What the programs we've been writing, they've been straight line path. Okay? And it is normally the default mode of use to execute programs. So sequential execution of codes statements is usually one line after the other. That is, from the top, moves from one statement going down until the program exits. That is sequential or straight line. Like if you look at the program for finding the area of a circle, the circumference of a circle, okay? Those are sequence structure because the execution is straight line, one line after the other. From the top, the last line. Okay? So all those programs you'll be running, the structure you'll be using is called sequential because it is one line after the other in that order in which those lines are arranged. And you notice that when you change you change the process. Like initially, some of you are confused where to put the process. You see the order is you get the input, you process, and you get the output. That's the order. The moment you change that order, the program might not run. But as you've seen, if you put that order where the program will give you the output. All those programs you've been writing, they fall under sequential structure, all the straight line path. Meaning that the execution follows a straight line, one line after the other, from the top to the bottom. The bottom, that is where the program exists, where it stops execution. Sequentially meaning one line after the other. Then the second one is the selection. The selection branch or branching. Okay? Selection. Or sometimes referred to as branching. Now this is used for decision or branching, and it performs by choosing between two or more alternatives. Between two or more alternatives. Like in, in the scenario which I was talking about, when you're going back home and you find the road is closed, what do? You have to make a decision, right? You have to make a decision, and that decision will lead you to branching to a different direction. That's why in selection structure, it's also referred to as branching. When you're walking home, when you're walking somewhere and you find the road is blocked, you make a decision, okay? Whether to go back or to use another route to proceed. So you see, it performs by choosing between two or more alternative paths. See that? And other selection structures, we have if statement, if else, and switch. These are the type of selections under selection structure. We have if. Because you are walking home or you're walking somewhere, and then if the road is blocked, what should I do? Should I go back to the house or should I take the path? Okay. Now, if if else, you see, you're walking somewhere, you're walking home.
Still, you are not audible enough.
Yeah, you must make sure your background is also quiet. Make sure you also increase your volume from your phone. Now, I'm saying if else, these are cases whereby, for example, you are walking in a path and you find that path is blocked. So if the path is blocked, you'll have to make a decision, okay, to follow another path. Now, what if that path is also blocked? Okay, you see, you have to take another path again. So if you take this, if you make this decision and the decision does not work, you think of another uh, decision to make. So if this one works, or if this does not work, you go to another option. And if that one does not work, else you select another one. So you find there is that if this one works, if it does not work, then else the other one should work. Okay? You see that? Then a switch, a good example to explain this switch selection structure is, you see, when you walk into an hotel, when you walk into an hotel, the first thing you look for, you ask is the menu. Okay, so you see this menu is just like a piece of paper or a booklet. So within that booklet or within that piece of paper, you find categories of food. Okay, categories of food ranging from maybe a soft drink, main meal, main dish, and so on and so forth. Each food item has a particular price indicated, a price tag. Okay? You have a list of food items within that booklet or within that sheet of paper, and each food has its price tag placed. So a switch is something like that, whereby you choose, there's a list of items, and each list has some value attached to it. And that's the scenario when you go to an hotel. Get the menu, you look at the food, each food has a price tag. So you select the food which you like and also which you can afford based on the price. For example, if you select number one is this particular food, and this food is costing this. Select number two, category two, these are the food, and if you select this food, this is the price tag. Okay. So that is the easiest explanation I can give you to help you see where a switch is used. Okay. Then the other category of this control structure, we have what we call the loop structure. The loop structure. The loop, or in brackets, we talk about repetitive of a set of activities. You see, some activities requires an, uh, an activity to be repeated several times. Okay? You need to repeat that activity several times for something to be done. Okay? Like if you want to, you are to write a program to display from number one to 100, or from number one to 10. So the activity of printing those numbers will keep on repeating, but checking the condition. There's always a condition. Just like you, first of all, the program will print number one. Then it checks if the condition has been met. You see, the condition here is to print from number one to number 10. So if you only print number one, then you check. Have you printed all the numbers? No. You repeat that activity, you print number two, then you check. If number one to 10 is not yet printed, you repeat that activity again. You print number three. So you see that activity will keep on repeating until the condition is met. Remember, the condition is write a program display from number one to 10. So you're not supposed to go beyond 10. So that is the condition. The condition is to print numbers from 1 to 10, but you don't pass 10. So you see, you keep on repeating that operation until those numbers are printed. You shall see using examples. So under this category, we have three types of loops: the while loop, the do while, and then the for. Okay? We shall see how they are being used as time goes by, because all of them will require we write a program to demonstrate. Like if you look, for example, in a while, you see we are repeating a set of activities. So someone is asking me to allow. Now, for example, when you talk about while while loop. You see, there in all these cases there must be a condition to be met. You see, for those who are coming in now, they are late, meaning that they don't know from where we started. You see, whatever we started discussing is leading us to where we are right now. Now, when you remember all these loop structures, there must be a condition to be met. It's a condition. So, as you're doing something, you must check whether it's that condition. Like in while structure, while the condition is being met, do the following. While the condition is being met, so meaning that the condition has to be checked first. The condition has to be met first. It's when this activity can be done. Okay? Like I've given you an activity, but this activity must be done in two groups. One group may be based on gender. One group should be the male gender, and the other one is the female gender. So the condition is while you are in this particular group, you must do this. Okay? So that condition must be met first for anything to happen. Okay? So while you belong to this particular gender, this is the kind of glue you should be using or you should be going. Like in most cases, we don't share glues with both genders have separate glues, right? So while you are in this particular gender group, use this particular glue. The same applies to while you're in the other category of gender. This is the glue you should be using. So the condition must be met first. When you talk about while, the condition has to be met first. It's when something can take place. But now, see, you are both the three classes from 1A1 to 1A4. Those are three classes. In fact, those are four classes, but I'm only seeing 60 people here, so I don't know where the rest. We have Anne in this group. We have Kabaraga in this group.
Yes, I mean.
And you refuse to submit the assignments. That one we won't talk about that again.
Really, heart of the man.
We have Hiram. Is Hiram in? How about Anne? This other gentleman, I can't remember his name. Okay. Now, in this other control structure, we do while. Remember, I said under while, first of all, the condition has to be met before you do anything. You must be a gentleman for you to use this particular loop. You must be a lady for you to use this particular loop. So the condition must be met first. Now in this second one, they do while. So in fact, this is the opposite of while. The do while is the opposite of. So meaning that you perform the activity first. Then you check the condition. See, that is dangerous. You perform the activity first, you do it. You do it first, then you check the condition. You see, if you go by the example I'm giving here, it's very dangerous. You know, Kambarate, you cannot walk into ladies' loo. It's when you, after using it, it's when you ask yourself whether am I in the right place. You see that? You're getting me? Going by this particular example, it's a dangerous one because you do something. It's when you ask yourself whether you follow the rule. So you do it, then while the condition is being met, you perform the operation and then you check whether was the condition met. So in some aspect of programming, first of all, you execute the statement or you perform an operation. Then later down there, you ask the condition. So you see here the condition is at the bottom. With the while structure, the condition is at the top. So you ask yourself whether is the condition met? Yes, then do A, B, C, D. But with the do while, the condition is at the top, meaning that you do all this, you perform all these instructions, you execute them. Then at the bottom there, you ask yourself, okay, while and do while. While the condition is at the top, first must be met, and the do while, you perform, you execute those statements. Then at the bottom, that's where you find the what? The condition. Then the for loop, it's normally, it is having around 3 parts. One part is where you do the initialization of the declaration. Of course, you're declaring a variable and assigning it the value at the same time. That is what is called initialization. So there is that part where you must declare the variable. Like for example, you can say int x is equal to maybe 0, for example, comma. Then maybe you say is the second part is the condition. Can be greater, you can say greater or equal to 10. And then remember that part, what we discussed yesterday. You can have plus x. Okay? So you can also have a minus like that. Okay? Or you can even have x minus or x plus like that. So a for loop has 3 parts: the initialization part, then the condition part, and then either the increment or the decrement. You see that the for loop has 3 parts: the initialization part, then initialization part, then followed by the condition part, and then the part which you either increment or you decrement. You see that? These are the 3 parts of a for loop: the initialization part, the condition part, and the increment or decrement part. Increment or decrement part, depending on what that program is all about. Okay? See, if you want to print, for example, number 1 to 10, meaning that you print number 1 in the first round. The second round, you increment that 1 by 1 so that it becomes 2, it prints. The second round, you increment that number 2 plus 1, it becomes 3. The 3 is printed. So you keep on incrementing until it reaches 10, then it stops there, because that's where the condition is. Okay? So this condition is very important. Or sometimes you want to print from 10 to 1. So you see, the first thing you need to print is 10. Then the second round, you decrement 10 by 1, it becomes 9. That's the case whereby if you have this as a minus minus, okay, like that. You start from 10, the first round. Second round, you decrement it by 1, it becomes 9. That is when you're printing from 10 all the way to number 1. So that's why you use the minus minus. But if you are printing from 0 to 10, then it means you print 0, you increment it by 1, 2, 3, 4, and so on and so forth. So that is under loop structure. And then those are the two categories. The selection structure or the loop structure. So these are the two categories. So under selection, you have if, else, and switch. And under loop, there you have while, do while, and for. Any question up to that point? Any question? Steve, any question? Just a minute. As you think of a question. Any question? I don't have any question. There's no question.
Excuse.
Yes?
Let me take you back to the if statements.
To them?
Uh, does nesting require a condition?
You see, I've talked about nesting up here.
Mm-hmm.
You see, nesting, those are different terms used. For example, when you are explaining about maybe the because we have if statement, then we have another version of if statement where we have if then else. So that's what we mean by nesting. See that?
Yeah.
So I don't want someone who has joined in late to start asking a question from where we started, because that one will be taking us back to Canaan. But we are taking us back to where we left. If you came late, stop asking me a question from what we just from where we left. Any other question?
Thank you.
And you see now, any other question before we move to the next thing, maybe in line with what you just asked, because that was just an overview explanation of what this selection and loop structure is all about. Because now we have to go to each and every one in details. Because you've been asked to write a program using if or if else or a switch. Any question? Any question?
Yes.
Ask.
What is the meaning of Boolean expression?
Is that Joy Wanjiru asking the question? Were you in class right from the beginning?
Yes.
You're asking about Boolean expression.
Yes.
But you see, it's not related to what we are discussing right now. You see, it is different. I want you to ask a question about what we're discussing right now. That is the control structures.
Okay.
I want you to ask the question based on what we're doing right now. Or maybe what we've done. You see, Boolean expression is a different thing altogether. Especially in electronics. That's why you'll hear such kind of statement, Boolean expression.
Yeah, about this while statement, huh? About the while statement, huh?
Yes.
Yeah, I think according to my notes, wamesema ati in a program about the semicolon, hapo ndo sielewi while program na semicolon. Would you mind ku-explain at least kidogo? Yeah.
Bernard, you see, we've not written any program. I'm just still explaining what they are. So if you're putting a semicolon, which semicolon are you referring to? Can you repeat your question? And maybe you need to be clear. Which semicolon are you referring to? Yes? Are you?
Like what I'm trying to say, see, naona inakuja the maybe ukiandika like before the uweke the usitake the program, eh? But yeah.
Yeah, I can hear you. Continue.
Yeah, so ndo sijaelewa about iti hiyo impact na semicolon ndo nauliza the impact.
You see, which semicolon are you referring to? Bernard, you see, I was just having a brief explanation about these control structures. I've not written any program.
Oh, sawa basi. I left then ukianza the program, eh?
The problem now, because if you keep on leaving and coming back, you leave, you come back, then you find yourself in the middle of nowhere. Because I've not written any program, I was just giving a brief explanation, brief description of these control structures. See that? Are you together?
Yes.
You see, most of you are not attending class, or most of you are not attentive. Then when I give some assignment, they are the ones copying. So when you copy, at the end of the day, you don't know what has been done. You see, right now, you are on your own. So the only thing you can do is to ask my friend to send you what he has done to copy. And that's what most of you are doing. So right now, you are not in a group like when you're in a class. Right now, you're alone. So if you don't attend these lessons well, you will not be able to get anything, because when you're asked to do something, you'll be seated there alone. Unless, like in some people and the kind of program they're writing, it tells me that there is someone who is helping them. But you see, even making things worse by subjecting them to some complicated things, some complicated programs. You see that? So we normally start from a simple program as we proceed with a complex one. Like you see, I said you are around 150, around 150 or 140. But in all the lessons, I always see around 60 there. So during the rest, they don't mind, they don't bother. The same as apply as happened with the assignments. The first one, maybe a half, manage to submit. And you see with the system, the moment the, the due date is over, it will not allow you again to submit. Now, I want us to look at if this if statement is selection now when using if or else, this evaluates condition if it's true. Okay. Now a single or block of statements are executed, otherwise another single or block of statements are executed. Now we say if this condition is if this is true, then this block of statement is being executed. Else another block of statement is being executed. If you're walking home and as usual the path is clear, you will go home, you reach home. But if you find the path is blocked, you will branch to another direction. So that direction is what is being referred to as another block of statement. In programming, those are statements. Now the else can optionally be present along with the if. Hence, else, if. If you look at the syntax, it is if the condition is met, then that statement or block of statements, you can see here, these are block of statements. It's a block of statements. The statement. Remember, up here we say a single or a block of statements are executed. Okay. Otherwise, another single or block of statement is being executed. Like that. So this is the syntax. This is the outline of the blueprint which the if statement takes. If condition, then a statement, one statement, or if condition, then a block of statement executed. It can be statement 1, statement 2, 3, 4, etc. Okay? So this is a single statement or a block of statement. If the condition is true, this can be executed. If the condition is true, then this block of statement is executed. Now,
Tungano ketukiwa.
because we talked about the if else,
June.
the first one is if without the else part. Okay. Now the second syntax is where we have now the else. If the condition is true, then the statement. Else, see, if this condition is true, then you execute this block of statement. But what if it is not true? Then you go to the else part, and then you execute this block of statement. This first statement is executed if the condition is true. But if this condition is not met, if the condition is not true, then it jumps to the else part. So under else part, there is an alternative. Okay? if you are walking home and the path is straight, then you continue walking, you reach home. But if the road is blocked, then you find another route, the else. The else part will give you an alternative route. Okay? This is where we have just single statement, but if you have a block of statements, but if the condition is met, then perform this number of statements, this block of statements. Okay? And if this condition is not true, then you jump to the else part. And under the else part, you also find another block of what? Statements. Okay? You also find another like that. Then that just reduce the spacing so that you can more. Now, I want you to have this program, you write it in your book so that you will try it, because you will not do more than one copy. Right? You copy this program. Now, this is a program. You need to have it in your book so that you can write on your own. This is a program that accepts two integers. The integers are numbers, 0 to 9. Then compare their values to see which one is bigger. This is the name of the program. Okay? To see how we can implement the if and the if else.
We have not written.
You have not written. Panda kidogo.
Then what are you doing?
We have not written.
What are you doing? Instead of writing, you're talking to me. Write it.
Shayuka, unaweza ipandisha hapo juu kiasi.
Si chini juu.
Why can you write faster? Are you through?
Yes.
Not yet.
Even writing is a problem. Where is the problem? Even copying, you're taking that long. Now, as you do that, within that two PDF files I gave you, you transfer all these control structures with some other examples. So apart from this, make sure you also check and get another program for if and if else. So then you're going to have at least two programs, two or more, depending on your interest. What I'm saying is check those two PDF files, you will find the same thing we are discussing here. But I want you to only focus on the if else part. Because that is what we discussed today. If else. So you try this program and the other one, or many others, depending on your own initiative now. Now, as usual, you see, we are making use of the structure of a C program. You can see the heading, all of the same. Sometimes you can even avoid this statement void, or you can include this. But then, again, when you include void, then it means some of the small errors will be omitted. Okay? So from here, you can see programs right there. Yeah. So we will get a variable because you see the program wants to compare or accept two values or two integers. So it's very difficult at the back of your mind you can see you are required to declare four variables because each integer must have a variable. And remember we said when we declare a variable, it means a memory is being set aside for those two variables. Now once you declare them, now you get the value into those variables. Like now use the scan F for A and B. Then remember we discussed about relational or we have the operators. We discussed about the operators. So as you can see, we are moving deeper and deeper into programming. We are now making use of what we learned. Now you can see one of the operators is then greater than sign. So meaning that you must also be referring to that topic where we discuss about the C operators. So this is where this is the topic where most of these operators will be used. This is where the operators are going to be used more often. So you see now, like the current assignment, which you don't need to submit, but make sure you do it and then you write it in your book. It's about writing the algorithm, then the flowchart. Okay. Like you see, if you look at this particular question, you have to write a program that accepts two integer and compares their values. You see, before you even go to the program, even before you even starting of the program, you should ask yourself, what are some of the inputs here? the inputs are going to be two integers. It can be x and y. What is the process to compare those two values? And then where is the output? The output is the result. Okay? And that's why that assignment you have currently is very important. Make sure you do it genuinely. Both the algorithms and the pseudocodes plus the flowchart. Because in each and every control structure, you must draw a flowchart. After the flowchart, you'll be required maybe to write an algorithm or a pseudocode. And then number 3, you now write the program. Given a scenario like this, a program that accepts two integers and compares their values to see which one is bigger. So part 1, you'll be asked to write an algorithm for this. Number flowchart. And then number 3, now write the program. So those 3 things normally accompany each other. That is why you must take the time, read the notes I've given you, and then try that work. Now, an algorithm for this will be, because any program must have an input, there must be a process, and then the output. So the input here are the two integers, for example, x and y, or a and b. Those are the inputs. Now, these two inputs are supposed to be processed. So what's the process? The process is now where we are comparing these two values. We compare between a and b or b and a. That's the process. And then what's the output? After you compare them, the output can either be a b or an a, depending on which one is bigger. So given a scenario like this, you ask yourself, what are the inputs? What is the process? The process will be to compare the values. Maybe compare a and b. The two inputs are a and b, or x and y. The process is to compare between a and b. And then the output is display the bigger between those two numbers. So always that is what you bring into your mind, and that is what that assignment is all about. Writing an algorithm or a pseudocode, drawing a flowchart, and then now writing the actual program. So like this part, the things which are needed here, what are the two variables that A and B? Okay? What is the process? This is the process. Okay? And then what is the output? The output can either be either this or this, depending on which one is bigger. So you compare between this and this. Meaning that if A is greater than B, then this statement will be executed. And if it is not the case that B is greater than A, then the second line will be if A is greater than B, then A will be displayed. But if A is not greater than B, meaning that B is bigger, then the else part will be displayed. That's why you can see B is being, you see here what is being placed first will be the result after the comparison. Like if A is greater than B, then A will be displayed. But if it is not the case, then the else part is executed. That is B will be. Okay. So depending on this comparison, this process, either this or that will be. And that is what this experiment is all about. So normally the condition is tested first. If it is true, then A is greater than B, and the output to this effect is given. And if it is false, then B is greater than A. and the output of this stage reflects this part. So I want you to know that program and you will try it. Then you go to those two PDF files and get two more examples of it else. Now, the question. Time for question if you have. Question. Vivian. Munta. Good question.
Yes, I have a question.
Yes.
I have a
Yes,
question.
go ahead.
Okay, in the previous programs, you've been writing the format specifier of integer. That is %d1.
Yes.
The format specifier of integer. But now in this program, I can see you are. But now in this program, I can see you are writing the format specifier 2 times. Now, what is the reason?
You see, you have not been attending class. That's why you are asking me the same question which was asked sometimes back. Did you write the notes about the format specifier? Did you? Solomon. Solomon. Solomon.
I've been attending all of them, but now I just want to know why
I want you to respond to what I'm asking you.
why you are using the both format specifier 2 times in a program.
I want you to ask me a question and I want to answer you. First of all, did you write program for modular operator?
Yes.
Did you write the program about the modular operator? Did you?
Yeah.
What is a modular operator? What is the function of a modular operator?
Yes,
what is the functions of a modular operator? Now, Solomon, are you there? Can you
a modular operator?
Can you find out the difference between modular operator and format specifier? If you do that, then that your question has been answered. Because those are areas you covered, but it means maybe to be attentive. The format specifier, the modular operator. Then from there, from there you'll see we are using the same sign but in two different scenarios. Any other question? I can see Solomon has left, meaning he was not interested with the response to this question. Any other question?
Yes, I have a question.
Yes.
After the integer a, comma b semicolon, then print f enter 2 in. So since we are inputting 2 integers, necessary to add a comment, see taking multiple inputs.
Can you repeat the question once again and be loud so that we can hear you?
Oh, I'm asking, after f, then brackets, enter 2 integers. So will it be okay if someone adds a multi-line comment since we are inputting 2 integers, taking multiple inputs?
You see, with the comment is a note to explain the program. So it is up to you. We said that in these comments, it is you as the programmer to, if you want someone to understand more of the program, you include the comment. right?
Yes.
A comment is just a note. It's just like if you look at maybe the Bible you normally read at home. There are some verses you will mark with some pen or red pen or blue pen. What is it that? It's maybe to remind you sometimes later or to draw attention to that particular verse, right?
Yes.
Is that true?
Yes.
That is exactly what's happening with a comment. A comment is like you want somebody somewhere to understand what your program is doing. And for you to do that, use the comment.
Yes.
A comment is like a quote explaining something. And you see that explanation is not part of that program. So you can either omit it or include it. So if
Okay.
someone understand what this is all about, so you are at liberty to include that. Okay?
Yes.
You are
Yes.
at liberty to comment on that.
Yes.
That to tell us what that line is all about.
Another question.
Yes.
Can you be given a scenario where you use an integer and a float?
That is a question which someone asked me last lesson. Were you there?
Yes.
For example, you are writing a program to divide two numbers, like maybe like 22/7. That's the pi, right?
Yes.
You see, the resulting the outcome is a decimal point. So that pi should be a floating because floating point it means the number is a decimal. You see, if you're talking about the program to find the area of a circle, you know the area of a circle is the radius. But who said that radius must just be a whole number? Radius can be even a decimal number, can be 3.5, can be 1.5, can be 6. So it's easy to see which one is much better. See that?
Yes.
If you have to find the area of a circle, the radius can either be a decimal or a whole number. So from there, you need to decide whether do I give it an integer or a float. Is it clear?
Yes.
It is what you are doing that should help you to think of which data type should I use. Because if you don't deal with names or characters, your data type should be a character type. If you're dealing with whole numbers, that is integer. If the result of a particular operation is going to give you a decimal, then that result should be declared as a float. And when you are writing a program, maybe to find the circumference of a circle, you see you need a radius. Radius, you know, most of you are just trying to have a fixed mind. A radius can be a decimal, or it can be a whole number, whichever the case. So because of that, you decide whether should I give it an integer data type or should I give it a floating point, so that you can get something like 3.1, the radius of 3.2, the radius of 6, and so on and so forth. Is it clear?
Yes.
Yeah, that's the question.
I would like to answer that one question. And you the function of a module.
Yes.
It functions to give the remainder.
You see, okay, what you're saying is correct, but this person seems to be getting confused between, because in this particular example, he can see we are using that sign, that percent sign, okay, for modular operator, right? But at the same time, when you're using the format specifier, you see the format specifier, you use that sign plus the character that represents that particular data type. So this fella is getting confused. Why are we using them here? Are you getting me?
Sure.
That's why you need time and look at what are these format specifiers. Format specifier has two parts. One is that percent symbol, and the second part is that character in that letter which represents the data type. Are we together?
Yeah.
So that is one scenario. The second scenario is when now we are talking about modular operator. You know, the modular operator is that symbol. And that's what Solomon seems to be confusing here. That is a question which someone asked me, was it last week or I don't know.
Okay, excuse me, sir.
Yes.
I was the one who asked you that question last week, but now the place that I'm confused is where you are using the scanf. Why are you using the %d twice? That point is where I wanted just to confirm.
Yes.
I'm not confused.
And that is why, okay, now I'm getting you. That's why I remember I've been saying, make sure you are attentive in such kind of a scenario in class before we close. And this is what I said. First of all, I said, this example, you can say int x, okay? Also say int y like that. See that? Solomon, are you there? Solomon? Solomon, are you there?
Yeah.
Because I'm explaining this
Yes.
for your case. So if you're not there, I will not continue.
I'm listening.
Now, instead of doing all these things, because this is a waste of time, if you have variable x, y, and z, there are so many. Instead of each and every one of them is having this kind of thing, which is still correct. You see, these are variable x, y, and z. They are both of the same data type. See this. X, Y,
Yeah.
Z are the same data type. So instead of doing this wasting the same time, the other way of doing it is like this way. So X, Y, Z like that, and then you can make it like this. See that?
Yeah.
Now, this is one example. The second example is now what you're asking me. Yeah? So, this and this is the same. But now, for the purpose of understanding and what you're asking, instead of this, I want to copy this 3 times. So, not 3 times, but 5. So, the only thing I can do here, Solomon, are you doing that? Solomon, are you seeing that?
Yeah.
So that's what you're asking, right?
Yes.
Are you answered?
Yeah. Yeah. So can I use? Let me ask a question again.
No, is this one clear first before you ask me anything else?
Yeah, it is clear. So can you again rate the scanf and maybe say you use the percent and the character, Then instead of using both writing the programs twice, the statement twice, module operator, then you write A, comma, B, then you close the statement, then you a semicolon. Is it the same?
When you're using what? When you're using what?
Okay. In this, okay, I'm just saying, like,
Yeah, that you can hear.
I'm saying,
Yes.
you have written the statement twice, and I get it.
It is the same as the first one, right? Solomon. Are you there? I see Solomon is not there. Any other question?
Teacher, I think he is asking whether we can use a single command specifier kuandika like instead of double command specifier then kuandika A and B.
You see, I've given you two scenarios, so you should not start thinking of anything else, right? You can have them in one line, or you can separate them. Each is supposed to have its own. Like what Solomon has just asked. So you don't start confusing again. I've given you what you should do in either case. You can use any of them.
Okay.
Yeah. Any other? Any other question?
No.
Now I said you write this program, try it, and then open those PDF files and get two more programs under if else. So.
Yes.
Yes.
Now that is your work to do.
Pardon.
If you have any question, ask now because we're almost ending. Any question? Any more question? So we can end it there, right? And you should be showing us what you've done. Remember, this is programming. So what I want to see is the screenshot of the program running. For those who are writing for me and then taking a picture, I won't accept that. You must do the program and let me see from your screen. We are not writing words here. We are writing a program. So we must see the program and the output at runtime. Those ones are a must. And that's why most of you are scoring 0. Because I'm not after seeing whether you've written. You know, that is something which anyone can do. But I want to see the program from either the screen of your phone or maybe when you're using a laptop. So don't write for me in a piece of paper, then you take a screenshot. You take a photo, then you send it for me. That is not what, you can't accept that yet. Some of you are taking a pen and a paper, they write and then they take a screenshot, they convert into PDF and then they send me. That is not what we are after here. How's out?
Yes.
So
Yes.
end it there. I'm only seeing 35 people out of maybe 100. So meaning the rest are not concerned. Like this baby,
Thank you for the lessons.
you want to come in when the lesson is over. So I'm just denying because we are ending the lesson. So do the work and let me see what you've done so far. Otherwise, see you next time.
Thank you.